Okay, let's take a look at example number 4, which is a function with oscillating behavior. And again, we're going to investigate the limit as x approaches 0 of sine of pi over x. Now, again, we can say that when f of x is equal to the sine of pi over x, okay, it is undefined where x cannot equal 0. Now we can evaluate the function for small values of x. Okay, so what happens? Okay, let's evaluate the function for when x is equal to 1. So if we take f of 1, then that is going to equal the sine of pi over 1, which is the sine of pi. And the sine of pi is equal to 0. If we take f of 1/2, so that would be the sine of pi divided by 1/2, which is the same thing as sine of 2 pi, which again is going to give you 0. If we take a look at f to the 1/3, so this would be sine of pi over 1/3, which again is the sine of 3 pi, which equals 0 again. If we take a look at f of 0.1, which is equal to the sine of pi over 0.1, well, that's the same thing as the sine of 10 pi, which again is equal to 0. And if we look at f of 0.01, that's also equal to the sine of pi over 0.01, which is equal to the sine of 100 pi. And again, that equals 0. Okay. Now, if we continued, okay, and continued, we would see that regardless, you're still going to get 0. So by looking at these scenarios and guessing, we could be tempted to say that, okay, the limit as x approaches 0 of the function sine of pi over x is equal to 0. Okay? But in this case, our guess is actually wrong, because notice that although if we look at f of 1 over n, and we can call n whatever number that we want, right? That would equal to the sine of whatever n is times pi, and regardless of whatever n is, it's still going to give us 0 for any integer n. Okay? But it is also true So it's also true that f of x, meaning the output, is equal to 1 for infinitely many values of x that approach 0. Okay, so when we look at this graph here, you can see that it's oscillating here. Okay, so as it's approaching here and here, you can see that it's approaching the value of 1. So the dashed lines near the y-axis here, okay, indicate that the values of sine of pi over x oscillate between -1 and 1 infinitely often as x approaches 0. So, since the values of f of x do not approach a fixed number as x approaches 0, then what we would say for this result is that it does not exist. So we would say that the limit as x approaches 0 of the function sine of pi over x does not exist. And then sometimes we just abbreviate that as DNE for does not exist.